Okay, last two concepts for your test. We have accuracy, whoops. And precision. Two different words, two different definitions. We'll start with accuracy. Okay. Accuracy it's how close your measurements are to being correct. And that's your keyword with accuracy, how close they are to being correct. Here are some examples. Okay, we know from our metric conversion factors that 1 kilogram equals, that was a terrible equal sign, equals 1,000 regular grams. So let's say we set up a lab experiment where we start adding grams to a balance until it hits exactly 1 kilogram, which should be 1,000 grams. But we end up with, we'll do 4 trials. We say one time is 999 grams. We have another trial that says 1,003 grams. Our third trial says 920 grams. Whoops, that one wasn't very good. And then our last one, we finally get exactly 1,000 grams. Now, when we're talking about accuracy, it's how close we are to perfect. So 999 is only one off. That's pretty close. 1,003, that's pretty close. And 1,000 grams, dead on. So these three are all accurate. Accuracy, how close you are to correct. In this case, our correct value was 1,000 grams. We had 3 of our 4 trials were pretty close, so those 3 are accurate. And we'll go with stereotypical red. 920 is wrong. That was not accurate. Sad. Oops. There we go. And we'll go back to black. Boop. And erase. Okay, now precision. Ooh, that was janky. Precision it's how close your measurements are to each other. So this one, we don't care how close they are to the correct value, we care how close they are to each other. And we'll use that same example we were just using with the 1 kilogram equals 1,000 grams. Each other is your keyword there. Okay, so back to our original 1 kilogram equals 1,000 grams. Now we set up the same experiment, but this time we had a group that accidentally thought that it was 100 kilograms. So they measure out 99 grams, 100 grams, 100 grams, and 99 grams again. All 4 of these are close to each other. They're all off by only 1. But we were looking for 1,000 grams, not 100 grams. So they're super far off by an order of 10 to our correct value, but they're close to each other. So these ones would be precise. But sadly, they are not accurate. Oh no, sad face. Those are his tears because he's not doing well in science. Okay, now we'll do what we're aiming for in the lab. We want precision and accuracy. Ooh, that's a terrible eye. Precision and accuracy. We need both. So we'll use that 1 kilogram equals 1,000 grams, example 1 last time. Oops, not a comma, equals. There we go. 1,000 grams. Now let's say we had a group that knew what they were doing, so we end up with 1,000 grams, 999 grams, 1,000 grams, and finally 1,001 grams. Now these answers are all what we were looking for. These two aren't exact, but they're pretty close. They're off by 1 over a course of 1,000, so that's 0.001% error, which is in another video. So these are all very close, and they're all very close to correct, so this is precise and accurate, which is what we want in our lab.